How do you build React.js? What's up, people? It's DevSage here, and I'm releasing my first course. I'm going to be teaching you how you can build your own library like React.js. There are a whole bunch of tutorials out there already about how you can build this application with React or that application with React. But there aren't as many courses or tutorials about how you can build your own React, your own libraries, your own frameworks, your own CLIs. And so I wanted to start getting into that space. I wanted to start teaching people how they can build their own tools from scratch, how they can learn the fundamental building blocks of the tools that they probably use every day. It's going to help you deepen your understanding of why your tool works the way it does, and being able to build your own tools. I mean, that's a superpower in and of itself. That's what's going to attract hiring managers and recruiters. That's what brings you from good developer to great developer. That's going to put you on the next level. So I hope to start making more of these courses about how you can build your own X, Y, or Z. And I figured I'd just start with React. So if you want this course, go to buildreactjs.io. That's buildreactjs.io and click the pre-order button on the website. The course is currently available for pre-order all the way up until launch date, which is going to be the week of August 22nd. So all the way up until August 22nd, you can pre-order the course. But once the course is launched, the price will go up. So if you want to get in on the bottom, if you want the lowest price you're ever going to see for this course, go ahead, go to buildreactjs.io and pre-order the course because the price will be going up. Who is this course for? So this is not a beginner level course. You should at least be comfortable with JavaScript. You should be maybe an intermediate to advanced level JavaScript user. And you should definitely be familiar with React. You don't have to be the best React developer, but you should be comfortable with concepts like JSX and virtual DOM and such. So that intermediate to advanced level JavaScript engineer, this is who that course is for. That wants to deepen their understanding about how React works under the hood. We're going to be looking at some more advanced concepts such as recursion and trees. So it's all right if you don't have a whole bunch of experience with trees. I'll try to, you guys know how I like to explain things, real simple. So I'll do my best to try to explain it in such a way that it just makes sense, even if you don't have any prior experience. But you should probably have at least a little bit of an understanding about what recursion is and how it works. And if you don't, I do have a video about recursion. I'll probably pin it up here in one of these corners right here, but do be sure to brush up on your recursion just a little bit. So the rest of this video is going to be a preview about what you can expect in this course. All right, so the first thing we're going to want to do is we're going to want to grab this starter code from the repository that I created. So if you go in the description or in the pinned comment, you should find a link to this repo called Sage Starter. So the name of the library that we're going to be creating is going to be called Sage. So when you get to this page, be sure to follow me on GitHub and also star the repository when you get a chance. But once you do that, come back to this page and let's go ahead and get the clone link. So let's copy this. Let's open up the terminal. Let's go ahead and run git clone and pass in the link. All right, let's go ahead and open this up in VS Code. All right, let's drag this over. So the project structure here is pretty bare bones. It's basically just the boilerplate code for a basic React 16 project. So we just have some basic Babel configuration, Webpack configuration files. Our index.html is here. And then also we have our index.js, which contains the actual React application. And this file is where we're going to spend the majority of our time. And the program here is pretty basic. It's just an H1 element, and then we're grabbing our root element and we're rendering our H1 element to the root. Some pretty basic React. So what we're going to end up doing is we're going to deconstruct this simple React application line by line to see what everything looks like under the hood. And then we're going to take what we've learned and apply those principles to build our own library back up from scratch, Sage. So let's first turn our attention to line 4 here, this basic H1 element. If you're familiar with React already, you probably already know that this H1 here is JSX. It's not HTML, even though it may look like it. You could pass in valid HTML here, or you could pass in any React component. And it's basically just a way to describe to React what the UI should look like, passing in either valid HTML or React components. But what we're going to focus on what this does under the hood, because obviously the browser does not understand JSX. The browser understands HTML, CSS, and JavaScript. So we're gonna deconstruct to see what this gets turned into, so that the browser and so that React can parse it and display something on the page. All right, so let's go ahead and comment this out. And so we're basically just going to rewrite this in a way that shows us what this gets turned into. So we're going to say const element, and we're going to say React.createElement. And this create element function is going to take in 3 arguments. It's going to take in the type of the element you want to create. In this case, the type is going to be an H1. So let's say H1. And the second argument is going to be any props or attributes associated with this element. In this case, we only have one attribute, which is the title, web dev made simple. So we're going to pass in an object that says title web dev made simple. And the third argument that create element takes in is going to be any children of this element or component. In this case, the only child that we have is the text DevSage. So we're going to pass in DevSage as a string. This could be an array if you had multiple children inside of here, but in this case, let's just pass in the string DevSage. All right, so this is basically what this JSX is going to be transformed into under the hood when you run the program. React is going to create a whole bunch of these React.createElement calls for each piece or for each element in your JSX that you want to render. And that createElement call is going to have the type of element you want to create, any attributes or props you want to pass that element, and any children you want to pass that element, whether that be an individual string here to be a piece of text, or it might be an array of other React create element calls. All right, so that's cool and all, but we actually have one more transformation that happens. React.createElement here, this is going to get transformed again into a plain old JavaScript object literal. So that's what React.createElement returns, a simple JavaScript object. So let's see what that transformation looks like. So we're going to comment this out, and again we're going to say const element equals some JavaScript object literal, and it's going to have the shape of, it's going to have a type, which is going to be, in this case, H1. It's also going to have props, which is going to be an object, which is associated with whatever properties or attributes you want to pass your element. In this case, remember our attribute that we passed in was title. So we're going to have a title prop, web dev made simple. And then inside of this props object, we're going to have a children array here, which is going to represent whatever children this element has. In this case, remember, the only child that this H1 had was the string DevSage. So in this case, instead of being an array, we're going to pass in the string DevSage. And that's what createElement does. So as you can see, there are a couple of hops and skips that we have to take to get from JSX down to this object literal that React can take in and use to figure out what the DOM should look like. All right, so we've deconstructed this JSX. Let's take a look at deconstructing this render function here. How does this work? And so, as you probably already know, render is going to take in some React element that you want to render to the screen, and then some container that you want to render it to. In this case, it's going to be an element with the ID of root. So let's focus on deconstructing this. So how do we recreate this? So let's comment this out and also this for right now. And let's just say const container equals document.getElement by ID root. So we're basically just doing the same thing we did here. We're grabbing the element with the ID of root. And so the idea here is we have this element in our hand, this plain old JavaScript object that represents the JSX that we originally had. And so we want to be able to look at the properties in this object to figure out what we want to render on the screen. And so we have enough information to do that. We can see that the type of element we want to create is an H1. So down here, we can say something like const node equals document.createElement, and then we can pass in element.type, and that's going to map to H1. So this document.createElement method, it's going to take in some element type, whether it be H1, div, span, whatever, and it's going to create a new DOM node of that type. And now what we want to do is we want to set any properties or attributes that this H1 has. So remember, our attributes are going to be in this props object. So we're going to have element.props.title. So let's say something like node, and the way we can set an attribute is by saying node title, in this case, equals element.props.title. All right, so we've created the DOM node by looking at the element type, and we've added all of the properties that this element has by looking at the props object here. The only thing left is to add any of the element's children. So in this case, the only child this element has is DevSage. And so we're going to go down here. We're going to say const text equals, and we're not going to inject our children into the DOM directly. In this case, we're going to create a text node for that. And we're going to take the text node, and then we're going to append it to the original node that we created. So let's say document.createTextNode, and then we're going to say text at node value, setting the node value property, equals element.props.children. All right. So we have the new element type. We've attached all the element attributes and its children. All right. So the only things really left to do are to, first of all, append the text node to the original node that we created, but then append the original node to the container that we originally specified, which is the root. So we're going to say node.append child text, appending the text node, and then we're going to say container.append child node. Okay, so we have deconstructed this JSX down to createElement, down to this original plain old JavaScript object. And we've also deconstructed the render function a little bit to see how React might take a regular JavaScript object and look at its properties and see what to put and how to put those elements on the screen. So let's actually run this code in the browser to see how it looks. All right, so let's open up our terminal, and inside of our Sage starter folder, we're going to want to run npm install because we hadn't done that earlier. All right, so now that we've done npm install, we can run npm start, which should go ahead and start the server. All right, so let's go and open up our browser. All right, so we have DevSage here. It's not very exciting, but this is just basically to show you the deconstruction of how things work. Remember where we originally started. So we originally started with this JSX, and we're gonna comment this out. And we started with these 3 lines, and we've deconstructed it down to see what React might actually do to the code to get it to display on the screen here. So we can take that knowledge and actually apply these concepts to basically rewrite our own create element in our own render functions in our custom library, Sage. All right, so let's go back to square one. We're going to remove all this deconstruction code that we had earlier, and we're going to be left with our original example. And we're going to change this example a little bit. We're going to modify this element by surrounding the h1 with a div. So let's put this at the end here, and let's give this div a style of background orange and color white. And let's change the text to Sage library. All right, so now that we have an idea of how React is going to transform this JSX and how it uses this in the render function, we can take those principles and that knowledge to write our own Sage.createElement and Sage.render functions. So we're going to need to create our own Sage.createElement function. We're going to tell JSX to compile down into using Sage.createElement instead of React.createElement. And Sage.createElement, in the same way as React's, is going to return an object literal that describes what DOM nodes should be created. And we're going to create our own Sage.render function, which is going to take in that object literal, which describes how the UI should look, and it's going to create all the necessary DOM nodes with the appropriate properties and children. And it's going to add each of those nodes to the DOM on the screen. All right, so first things first, we're going to recreate our createElement function. So let's say function createElement. And this is going to take in 3 arguments: the type, the props object, and then any children that we pass in. In this case, when we call createElement, we can pass in as many individual children as we want, but we want to end up basically collapsing all of those children down into a single children array. So we're going to be using the rest parameter to do that. And so inside of here, remember, createElement is just going to return a plain object literal. So let's just say return an object literal that has a type of type, and it's going to have a props property. And inside of this props property, we basically want to take all of the props from this object literal that we passed in and add all of those inside of here into this new props property. So we can do that by using the spread operator, by using ... props. So whatever props that we defined inside of this object literal, those are going to be passed through and they're going to be spread out into this new props object literal. Okay, and now we have to worry about our children. So let's say children, and remember, children is just going to be an array of all of the children objects for this particular node's children. So we could leave it like this, but we're going to run into a problem because a child object could be a regular old object literal that gets processed from, let's say, this h1, for example, or it could be a child that's literally just this text, Sage library. What we're going to want to do is, in the case that it's just text, we still want to return an object literal. Right now, it would just be returning the text itself. So we need to create a special kind of object specifically for text elements that we come across. So we're going to want to map over all of the children here. So let's say children.map, and then let's say child. And if the type of the current child is already an object, then cool, we don't need to do anything special. Let's just return that child. So let's say if type of child equals object, then just return child, no problem. If this is not the case, then that must mean that the current element we're processing is a text element. So we're going to want to return an object literal all the same. So let's do that by saying return, and we haven't defined this yet, but let's say return create text element, and we're going to pass in the child. And so let's define this. Let's write our create text element function, which is going to take in some string of text and return an object literal that represents this text that we're processing. So let's say function create text element text, and let's say return an object literal that has a type of, let's say, text element. And then it's going to have a props property that's going to have a node value of text. And it's going to have no children. Okay, cool. So that pretty much covers it for create element and create text element. Now let's figure out how we can tell JSX to basically not use React.createElement, but use our create element instead. How can we do that? First of all, let's go up here and let's create our library. So let's say const Sage, and this is just going to be an object literal, and we're going to expose the create element function from it. So now let's go down here on the line right above the JSX element, and we're going to create a pragma, which is basically just an instruction to tell JSX what function to use to process this. In this case, we do that by creating this comment, and we're going to say at JSX, and we're going to pass in the function reference. So in this case, the function reference of the function that we want to use to process this JSX is going to be Sage.createElement. And so that's how we do it. That's how we tell JSX to use our own custom function instead of just relying on React.createElement. So when this gets compiled down, it's going to get compiled down to a whole bunch of Sage.createElement calls instead of React.createElement. All right, so now that we've created our own Sage.createElement function and told JSX to use this function, let's create our custom render function. So let's go down here and let's say function render. And remember, render is just going to take in the element you want to render and the container you want to render it to. So let's say element and then container. And let's go ahead and expose this render function from our library here. So let's just add render up here. And let's go ahead and figure out what we need to do inside of render. So there are a couple steps that we need to do inside of this render. So step one is we need to create the DOM node that we want to render. So let's say create DOM node. Step two is, now that we've created the DOM node that we want to render based off of the element type, we need to actually add all the properties and attributes to this new DOM node that we just created. Add all properties / attributes. Step three, now we need to add all of this DOM node's children. And then step four is just to render the DOM on the screen. Okay, so let's go to step one, create the DOM node. So we're going to create a new DOM node based off of the element type that we passed in. So let's say const DOM equals, and we're going to create a DOM node based off of, if the element is a text element type, then we're going to create a text node. Otherwise, we're going to create a regular DOM element, and we're going to look at the element.type. So let's say element.type equals text element. If this is a text element, then document.create text node. We're going to pass in the empty string. Else document.createElement looking at the element.type. Okay, it's pretty straightforward. So we've created the DOM node. Now let's go through all the properties from element.props and add all those properties to this new DOM node that we created. So let's say object.keys element.props for all of the keys in the props property. Let's go ahead and run for each of those prop names. We're going to set DOM at prop name equals element.props at prop name. All right, so this code is looping through all the properties in element.props and adding that prop to the DOM node that we created. But we have a problem here because remember how this is structured. inside of our props property, we have our children property, which is not something that we actually want to attach to the actual DOM node. This children property is specific to Sage understanding how it needs to process things. So we don't actually want to include it in any of the DOM output. So we actually need to filter out the children property. So before this for each, let's say dot filter, let's say key, and let's say if key is not equal to children, then return true. Cool, return it and allow it to be used for the next step. If it is the children key, then it's going to get ignored. It's going to get filtered out. So now we don't have to worry about that. All right, so step 3 is we want to render all of this node's children. So let's say element.props.children.forEach child. We're going to call render on that child. And remember, render takes in 2 arguments, the element you want to render, in this case the child, and the container you want to render it to. So let's think about this for a second. If we're trying to render the current DOM node's children, then the container for this render call should be the DOM node itself, right? Because element is going to get appended to whatever container we pass in as the second argument. So this child should have a container of the current DOM node. I hope that makes sense. And so what this is going to do, and this introduces recursion a little bit. So hopefully you're familiar with recursion at least a little bit. But what's going to end up happening is it's going to call render, passing in the child as the element and the DOM node from the previous step as the container. And it's going to do all this stuff over and over again. It's going to create the new DOM node for the child. It's going to add all the properties and attributes for it. And it's going to add all of that child's children. And it's going to keep repeating the process, stepping through all the way to the point where it doesn't have any more children to process. And then it's going to run this last step. It's going to render all of the elements on the screen. And so the way we do that is we say container.append child DOM. So that's pretty much it. Render is going to create the DOM node, add all of the properties and attributes to that DOM node, call render on all of the DOM node's children, and then it's going to render everything on the screen. All right, so we're almost ready to take a look at what this looks like in the browser, but we need to do one thing. We need to replace React DOM here with Sage.render. All right, so we've officially gotten rid of all of the React code. So we can actually just get rid of all of these imports at the top, save it, and let's see what this looks like in the browser. All right, so look at that. We have Sage library here. We have our div with an orange background and color white. And inside of that, we have our Sage library H1 with the title of Web Dev Made Simple. So look at that. We've just created our own library similar to React. We've recreated the createElement function and the render function, and we've told JSX to use all of our new stuff instead of relying on React's stuff. So this is just a preview of what this course is going to be about. So the full course is going to be focused on how can we optimize the render function to only update when it needs to, and to not have to render the entire tree every render. We're going to be looking at things like reconciliation. We're also going to be looking at how to implement hooks and how to add support for function components. And it's going to be great. So go ahead and pre-order the course right now while the price is low, because once the course launches, the price is going to go up. So go ahead and pre-order right now. Buildreactjs.io. Go ahead and check it out.